Part 1. The Paradox of Saving a Life. Good morning, or maybe good night. It's currently 3:02 a.m. I've just wrapped up my 11th case today? Or 12th? Honestly, I stopped counting around dinner time. The kind of night where the hospital feels like a second skin and time feels like a rumor. I should be getting some sleep right now. But before I hand things over to my registrar, who, by the way, is fully capable of holding the fort on his own, I wanted to share something with you. Two things, actually. Two strange, fascinating, almost maddeningly ironic concepts from the world of medicine. Things that should make sense, but don't, and yet they matter deeply. Now, I've hesitated to share this before because it can feel a bit niche, like something that belongs in a dusty academic journal with 3 readers and 72 citations. But since I'm in this phase of just speaking honestly, no flashy edits, no green screens, just me and my words, I figured why not tell you something I've spent years thinking about. It's about the heart and damage, and how sometimes saving someone can hurt them. Yeah, I know, it sounds backwards, but stay with me. Let's start simple. Part 2. When Saving Hurts, the Reperfusion Dilemma. So let's rewind. Imagine this. You're sitting at home, or at work, or walking your dog, and suddenly something feels wrong. Tightness in your chest. Maybe pain radiating down your arm. You try to shake it off, but your body knows better. A heart attack. What's happening here, medically, is that an artery supplying oxygen-rich blood to the heart muscle suddenly becomes blocked. Completely. No blood, no oxygen, no nutrients. Just silence in a part of the heart that never, ever stops working. And that silence is dangerous. So naturally, our goal is simple, right? Unblock the artery. Let the blood flow again. Restore life to the muscle. That's what I do. I'm what you might call a glorified plumber. A cardiac plumber, if you will. Catheters, wires, stents, tools of the trade to restore that precious flow. And most of the time, when we reopen that artery, it's like flipping a light switch. The patient perks up. Their color returns. Their chest pain melts away. We save lives that way. But here's the catch. What if I told you that sometimes the act of restoring blood flow can cause more harm? Yeah, that's the weird part. That's what we call reperfusion injury. And let me be clear, it's not a rare side effect. It's a well-documented phenomenon in medicine, though still not completely understood. Here's the paradox. You save a life by restoring blood flow, and in doing so, you trigger a second wave of damage. 2 hits. First hit. The heart muscle gets injured by the blockage itself. Starved of oxygen, those delicate cardiac cells start to shut down. Second hit. The moment you restore blood flow, the moment you think you're doing the right thing, you unleash a biological storm. Inflammation, swelling, cell death. It's like giving water to a person dying of thirst and drowning them. Sounds dramatic, but honestly, it's not far off. The statistics, and why you should care now. Before we dive deeper into the biology of this madness, let me give you a moment of hope. The mortality rate from heart attacks has dropped massively in the last few decades. If you're under 30, you might not realize that just 20-30 years ago, heart attacks killed a lot of people in their 30s, 40s, 50s. Dropping dead at work or on the football pitch wasn't unusual. But thanks to modern cardiology, drugs, stents, better emergency services, amazing nurses, rehabilitation teams, we're now saving more lives than ever. And that's why reperfusion injury has come into sharper focus. Because we've won the first battle, getting people to survive the heart attack. Now we're trying to win the second one, reducing the damage that happens after we save them. Why does reperfusion injury even happen? We're still figuring it out, to be honest. But here's what we do know. When a part of the heart is starved of oxygen for too long, ATP production, the cell's energy currency, crashes. The environment inside the cells becomes acidic. The cell membranes start failing. Sodium builds up. Water rushes in. The cells swell. And then, boom. We open the artery. Blood rushes in. Oxygen floods the tissues. But those damaged cells? They can't handle it. The mitochondria, remember they're like little power plants, are struggling. So instead of using the oxygen to produce clean energy, they start spitting out toxic waste. Free radicals, reactive oxygen species, superoxide, hydrogen peroxide, hydroxyl radicals. It's like lighting a match in a room full of gasoline. The aftermath. This toxic flood causes more membrane damage, inflammation, white blood cell infiltration, calcium overload. And trust me, calcium in the wrong place is like giving a toddler a box of matches. It wreaks havoc. This cascade of damage can make the patient feel worse after the artery is opened. Sometimes their chest pain actually increases. Sometimes their blood pressure drops. In rare cases, their heart function deteriorates right on the table. I've seen it. We all have. It's demoralizing. You do the right thing, open the artery, and yet the patient suffers more. But that's the nature of reperfusion injury. It's one of those cruel ironies that medicine is full of. No reflow when nothing happens. Want to hear something worse? Sometimes, even after we open the artery, nothing flows. We inject dye, expecting to see it gush through like a waterfall, and it just sits there, doesn't move. That's called no reflow. The blockage is gone, the stent is in place, but the tissue downstream is so inflamed, so swollen, that blood just can't pass through. It's like fixing. And again, it's heartbreaking. For the patient, for the team, for everyone. Because we did everything right. And still, the DA. This is why I chose to specialize in this field. Not because it's simple, not because it's glamorous, but because it's one of the last frontiers in modern cardiology. We've learned how to save the patient. Now we need to learn how to protect their heart from our own good intentions. Part 3, a simple trick to shrink a heart attack? So by now, we've walked through this bizarre paradox, how saving a patient's heart can sometimes hurt it. We've talked about reperfusion injury, no reflow, and the double hit the heart takes during a major heart attack. But now, I want to shift gears. Let's ask the question that's kept a lot of researchers up at night, myself included. Can we stop this second wave of damage? Can we somehow shield the heart from itself, from us? Well, as it turns out, there's been a lot of research trying to answer that. And one of the most curious, promising, and ultimately frustrating ideas came out of an experiment done back in the 1980s. And like many groundbreaking ideas, it started with a dog. The dog experiment that changed everything. So, picture this. Researchers block a coronary artery in a dog for a few minutes, temporarily starving part of the heart of oxygen. Then they release the blockage, let the blood flow return. Then they do it again. Block, release, like a kind of cardiovascular yo-yo. And finally, they induce a real heart attack, a full, sustained blockage. What they found shocked them. The size of the heart attack was smaller than if they hadn't done the whole yo-yo routine. This strange sequence of temporary ischemia and reperfusion, done before the real heart attack, somehow prepared the heart to survive it better. And so the term was born, ischemic preconditioning, like a warm-up set before the main event, but for heart tissue. But wait, it gets weirder. Next, someone wondered, do we need to precondition the exact same artery? Apparently not. Then someone else asked, do we even need to mess with the heart at all? Apparently not again. They discovered that if you caused temporary ischemia in a different organ, like the kidney, by briefly cutting off blood flow there, the heart still benefited. Even stranger, you could do this by inflating a blood pressure cuff on the arm. Just a regular hospital BP cuff. Inflate it for 5 minutes, let it down, repeat 3 or 4 times, and it seemed to trigger some kind of whole-body response. A signal, a warning, a preparation. T-heart was more resilient, more ready to endure the storm. And this became known as remote ischemic preconditioning. Sounds like a science fiction term, I know. But this was real, and it was measurable. The excitement builds. This discovery lit a fire under cardiology departments around the world. Because think about it. It doesn't require drugs, no fancy machines, no surgery, just a blood pressure cuff and 15-20 minutes. Every hospital already has that. Every ambulance too. No side effects, no cost, no risk. It felt like magic, or cheating, or maybe both. And the early studies, mostly done in animals or very small groups of patients, showed clear benefits. So the obvious next step was to test it properly in a big, international randomized trial. And that's where I come in, because that trial, I was part of it. When real life ruins good science. Now, before you get excited, let me spoil the ending. It didn't work. After years of hope, dozens of researchers, thousands of patients, and a mountain of effort, the study showed no clear benefit from remote ischemic preconditioning in actual heart attack patients. Heart attacks didn't get smaller, outcomes didn't improve. And I'll admit, it was deeply disappointing. We thought we had something elegant, simple, beautiful even. But as is so often the case in medicine, real life doesn't behave like the lab. So, what happened? There are a few reasons why it failed. First, timing. In most of the successful animal studies, the conditioning was done before the heart attack. But in real life, you don't get a warning. You don't say, "Hang on, I think I'll have a heart attack tomorrow. Better start preconditioning now." We tried doing it after the heart attack started, but before reopening the artery, thinking we could still blunt the reperfusion injury. But maybe that window was already too late. Second, modern cardiology has just gotten too good. The faster we open arteries, the fewer complications we see. The average time from ambulance to artery opening is now under 30 minutes in most countries. That means there's less room for new treatments to show benefit. It's like putting better tires on a rocket ship. At some point, you're already going fast enough that small tweaks don't make a visible difference. But it's not over. Here's the thing. Remote ischemic preconditioning didn't work in acute heart attacks. But not all ischemia is unexpected. What about planned heart surgeries, where the heart is intentionally stopped? Organ transplants, where a kidney is without blood flow for hours before it's reconnected? These are situations where we do have time. We can prepare. And so remote ischemic preconditioning is still being studied in those areas. I still believe in it. Maybe not as a miracle cure, but as a tool. One that just needs the right timing and the right patient. Sometimes science doesn't fail. It just doesn't fit the box we tried to shove it into. Part 4. The remote button that saves the heart. Let's talk about one of the strangest ideas to come out of modern cardiology. Ready? You can protect your heart by hurting your arm. No, I'm not kidding. And no, this isn't some ancient kung fu pressure point trick. It's called remote ischemic conditioning, or RIC for short. Picture this. Someone is about to have heart surgery. High risk, lots of blood, lots of variables. But before the scalpel even touches the chest, a nurse inflates a blood pressure cuff on the patient's arm, tight, like cut off circulation tight. They hold it for 5 minutes, then they deflate. Wait a bit. Inflate again, then deflate again. They do this a few times. Why? Because, somehow, this brief, controlled episode of blood flow restriction in the arm triggers protective signals in the rest of the body, including the heart. I know. It sounds like voodoo, but it's not. It's biochemistry. It's evolution. It's weirdly brilliant. What's happening here? Scientists believe that when you temporarily restrict blood flow to a limb, your body panics, just a little. Not enough to cause real harm, but enough to send out warning flares. Molecules start circulating. Mitochondria in cells perk up. Enzymes shift. The immune system goes into a gentle alert mode, and somehow all this prep work makes distant organs, like the heart, more resilient, stronger, better able to survive what's coming. Imagine it like a fire drill. You might not have a fire today, but if you've practiced what to do when it comes, you're less likely to panic and more likely to survive. Remote ischemic conditioning is your body's fire drill for trauma. And somehow, pressing the metaphorical panic button in your arm teaches your heart to deal with an impending attack. How is that not science fiction? Clinical trials. The mixed bag. Now, I'd love to say this works like magic in every patient, in every hospital, under every condition. But the truth, like always in medicine, is complicated. Some clinical trials have shown incredible protective benefits from RIC. Fewer arrhythmias, lower troponin levels, better heart function. Some even suggested lower mortality. But other trials showed very little. Sometimes no difference at all. Why? Well, here's the honest truth. Humans are messy. No two hearts are the same. No two surgeries are the same. And certainly no two hospitals, surgeons, or protocols are the same. There are a million moving parts. Maybe the cuff wasn't inflated properly. Maybe the timing was off. Maybe the patient was already on drugs that altered the signaling pathways. Maybe the body was already too damaged to respond. So yes, like many things in life and in medicine, it's not a universal miracle, but it's something. It's a glimpse into a truth we're still uncovering. And honestly, I find that exciting. Why should you care? Because if this works, if even part of it works, it means we're no longer limited to fixing the damage after it happens. It means we can start training the body in advance, teaching it to cope, to fight back, to build resilience. And it also means something deeper, that the body is more connected than we realize. Your arm and your heart and your brain and your gut, they're not isolated organs doing their own thing. They're part of one system, one whole. And sometimes helping one part prepares the others to survive. It's beautiful. It's frustrating. It's complex. And it's medicine. Science meets soul. The more I do this work, the more I realize that medicine isn't about certainty. It's about odds, possibilities, signals in the noise. We use science like a lantern, shining it into the darkness, hoping to understand what's out there. Remote ischemic conditioning is one of those flickers of light, a clue that maybe, just maybe, the body already knows how to survive. We just have to listen. And sometimes, we help not by doing more, but by doing just enough in the right place, like squeezing an arm to save a heart. Part 5. The irony of healing and the lessons it leaves us. So here we are. We've journeyed through blocked arteries, bursting vessels, biochemical chaos, and even bizarre rescue methods like squeezing an arm to save a heart. It's been strange, emotional, a little scientific, and maybe, just maybe, a little inspiring too. But now we reach the part where we pull it all together. Not with more data, but with something deeper. Perspective. The paradox of damage. Here's what I still can't get over. What keeps me staring at the ceiling some nights. Sometimes the thing that hurts us most is the very thing that's trying to help. A heart starved of oxygen suffers. But when blood comes rushing back, it suffers again, this time from the very act of healing. It's not malicious. It's not failure. It's just complicated. The body isn't a machine with clear cause and effect levers. It's a wild, reactive system trying its best, adapting on the fly. And sometimes, adaptation comes with a price. This isn't just biology, it's life. Emotional reperfusion. Injury. You want to get philosophical? Let's do it. Reperfusion injury isn't just a medical thing, it's also a human thing. Think about grief. You bottle it up, numb yourself, avoid the pain. And then, someday, you let the memories back in. You cry, you shake, you feel like you're breaking. But that pain? That's healing. It's your heart reoxygenating. It hurts, but it's part of coming back to life. Think about relationships. Someone betrays you. You close off, harden. But then someone new comes along, kind, patient. You let yourself love again. And suddenly the old wounds ache again before they start to close. Again, reperfusion. The return of feeling brings pain, but also repair, the kindness of time. Here's what I've learned from both hearts and humans. Healing can't be rushed. You can't flood a damaged heart with blood too fast, or it breaks more. You can't shove forgiveness into a wounded person and expect joy. You can't force recovery to happen on your timeline. You guide it, gently. You let it unfold. We call it gradual reperfusion in medicine. In life, we just call it patience. What the heart teaches us. So, what do we do with all this? All this strange knowledge, all this irony, all these painful truths? Maybe nothing. Maybe we just hold it. Maybe we stop expecting healing to be clean and painless and swift. Maybe we honor the fact that growth often starts with rupture, and that sometimes survival looks like weakness before it looks like strength. And maybe, just maybe, we can start seeing our own wounds differently. Not as signs of failure, but as signs that something inside us is trying desperately to live. Medicine beyond the body. You know, I used to think medicine was about fixing. Find the broken thing, patch it up, move on. But now I think it's about witnessing. Standing beside someone as their body fights to come back. Understanding that pain can be part of the rescue. Offering comfort, guidance, and sometimes just a blood pressure cuff and a prayer. That's not weakness. That's humanity. Closing thoughts. If you've made it this far, thank you. Seriously. This topic is heavy, not just medically, but emotionally. We've talked about dying cells, fragile vessels, and the bittersweet nature of survival. But behind all of that, there's this quiet, stubborn hope that life always wants to continue. The heart wants to beat. The blood wants to flow. The body wants to mend, even if it stumbles doing so. And so do we. So wherever you are, whatever your scars, whatever damage you carry, know this: you are not broken beyond repair. You're just healing in motion. And sometimes, that's the most beautiful mess of all. Take care of your heart, take care of each other, and let healing happen, even if it hurts a little at first. Thanks for listening. See you next time. Thank you for joining us on this deeply human journey into the heart's paradoxes. If today's story gave you insight, comfort, or even just a moment to pause, don't forget to like, share, and subscribe for more thought-provoking health content. And remember, healing isn't always clean, but it's always worth it. See you in the next epi.